put the heading as geometrical isomerism today. Actually, Nana, if CC single bond is there, free rotation is possible now. So we will discuss that is in the conformational isomerism. When CC double bond, free rotation is not possible. Free rotation is not possible. When CC single bond is there, free rotation is possible, right? For example, this is a CC single bond, so this is free rotation is possible. But whereas in case of CC double bond, free rotation is not possible. Write it down. In case of double bond, free rotation is not possible. For example, here is geometrical isomerism, particularly will speak about cis and trans. The groups are same side. We could say cis. If both are opposite side, now H3, H, trans. Cis and trans. Write it down. For example, what about this one? Cis. Trans. Cis, trans. This is cis or trans? That's all I'm asking. It's not a geometrical isomerism now. So particularly, write it down. AB, for example, CD, if A is not equals to B, or C is not equals to D, then only it shows the geometrical isomerism. Then it shows geometrical isomerism. Then it shows geometrical isomerism. In this case, what is A is equals to B? If C is equals to D, it won't show the geometrical isomerism. Write that point also. If A is equals to B or C is equals to D, no geometrical isomerism. If A is equals to B, C is equals to D, no geometrical isomerism. For example, is this cis or trans? Because here is C is equals to T, right? No geometrical isomerism. Not geometrical isomerism is not possible. Okay. For example, the alkene is like this. Now we can say, what about this? So particularly this one and this one, trans. Now this is this trans. Write it down. Trans. This already I know. We know cis, trans. Now the question is in cis and trans, no? Which is more dipole moment, more dipole moment is more polarity, is more boiling point, which is more melting point. Which of the following, right? More dipole moment, more polarity, more boiling point, more melting point. So in this case, Nana, it is what exactly happened. Chlorine is more electronegative, right? The electrons are moving this side. Dipole moment is not equals to 0. Whereas in this case, exactly opposite side. Dipole moment is equals to 0. Dipole moment is not equals to 0. Where? In this case. Because whenever the dipole moment opposite directions. For example, this is pulling this side and this is pulling this side. In opposite directions, what happens? One is pulling this side and one is pulling this side. So which side I used to move? That case is chlorine is moving that side and this side at exactly opposite sides. So dipole moment is 0. But only one side if someone is pulling. This is moving this side and like that. It's coming down. You can drag it down. So dipole moment is not equals to 0. So write one important point. Dipole moment is directly proportional to polarity. Dipole moment is directly proportional to boiling point. Dipole moment is directly proportional to boiling point. So now cis and trans cases. So which is more dipole moment? Cis greater than trans. Which is more polarity? Cis greater than trans. Which is more boiling point? Cis greater than trans. Which is more melting points? In this case, trans greater than cis. Why trans greater than cis means closed packing structure is possible. Closed packing structure. In the ends are opposite direction, so repulsions are less. So closed packing possible. Close packing is possible in trans case. Close packing is possible in trans case. Write it down. Next, in this case, if 4 different groups are given, for example, imagine fluorine, chlorine, bromine, iodine. So I gave the condition A is not equals to B and C is not equals to D. Of course, it shows the geometrical isomerism. But how can we say cis and trans in this case? How can we say cis and trans? In these cases, if the 4 different groups are there, so we will go with EZ. Right? EZ nomenclature. So here is E means what? E means what and Z means what? Antigen. E means antigen. Z means Zusammen. So Z means same side. Same side. Write it down. Same side. You like cis. E means opposite side. This we are called as Zusammen. Z means is antigen. Antigen means opposite direction. We need to do this. What is exactly? Here we have some CIP rules are there. Which rules? CIP rules. Kohn, Ingold, Prelog rules. Kohn, Ingold, Prelog rules. Kohn, Ingold, Prelog rules. First, what we need to do? So we need to divide like this. This side, left side. So first, what we need to do? Highest atomic number. We need to give the first number. What we need to do? Highest. Write it down. Highest atomic number. First, we need to give the first priority. So bromine and iodine, which is highest atomic number? We know top to bottom what exactly happened now? Fluorine, chlorine, bromine, iodine. So which is highest atomic number? Iodine. Iodine means this is first. Okay. Then this is second. In this case, fluorine and chlorine. Fluorine first, fluorine second. Fluorine is first, fluorine is second. Now try to understand. Right, here is what? First, here is first, second, second. The same side or opposite side? Second, first. Same side means what? Z. Z. If opposite side, if it is coming, write it down this. First, second, like trans mode. This is E. So first means same like cis type of mode, but it's not, we can't say cis. Instead of cis, what we could say? Z. If it is opposite side, like trans, but it's not trans, we have to say E. Now let me know, so which is EZ right now? Fluorine, hydrogen, fluorine, bromine, H3, so see Nana, if atomic number is same, so we need to go with the mass number, atomic mass. So first what we need to do, which is directly attached, first we need to cross check. First what we need to, highest atomic number, right? Highest atomic number. So then if the highest atomic number is same, we'll go with the atomic mass. Atomic mass. If both atomic mass is same, so then we need to go adjacent one. Adjacent one, we need to cross check like that. So come on, do it. 1, 2, come on, first I gave you a 7, so just do it. Right or wrong doesn't matter. So first one. So fluorine first, hydrogen is second, right? Here is bromine first, chlorine is second. Right, opposite direction. Opposite direction means E. Second one, hydrogen, deuterium, same atomic number. So need to go with the mass number. Nana. Deuterium is first, then 1, 2. Right, this is also E. Third one, fluorine is second. Of course, this is first, this is second. This is Z. Deuterium first, hydrogen is second. Oxygen and nitrogen. Oxygen 7, nitrogen 8, oxygen 8, right? 7, 8, right? 1, 2. Right? What, Nana? E. Fifth one. 1. This is 1, this is 2. 1, this is 2. Right? E. CH2, CH2. So that's what I'm telling. This carbon, carbon, same. Okay. So now the above 2 hydrogens are there, right? Below 3 hydrogens are there. So one hydrogen place, one OH group is here. This hydrogen cancelled, right? Then O and H, which one we need to give them? Oh, that's the first one. This is second. This is first, second, first, second. E. Here is first, second, Z. Right, when double bond and triple bond cases, what is a double bond? We need to understand. Hello. CC double bond means we have to write like this. Hello. CC double bond means C is having 2 carbons like that. For example, CC triple bond means 3 carbons like that. So obviously, which one we need to give the more priority? Triple bond. So this is first, this is second. First, second, right? Z. In this case, Nana, this is one of the important thing when small ring and big ring is there. So generally, a lot of students, 90% of students will do the mistake here. So generally, all students will give the big ring, but we need to give the priority to small ring. First small ring, second big ring. This first. This is second, right? This is E. So why small ring gets more means, so here is try to understand 1, 2, 3, 4. 1, 2, 3, 4, fifth row. So means, try to understand here. So CH2, 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 fourth one is having 2 carbons. 1, 2, 3, 4. This one. Whereas in case of fifth row, first CH2, 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 C is the fifth carbon. 1, 2, 3, 4. Fifth carbon is having the CC. So in case of while we are giving the priority, so first which is coming first, we need to give the more priority. So for that purpose, small ring, right one, small ring, more priority than big ring. Write it down. Here is 2 iodines are there, but those are present in the second carbon, 1, 2 position. But in this case, first one, chlorine is there. So means compare the first carbons first. So first carbon is having 2 hydrogens and 1 carbon. This is first carbon. Hello. Second carbon, 1 hydrogen, 1 chlorine and 1 carbon. Right? So now which one will get the more priority? Down one. Right? The first two, which is directly attached, that we need to cross check. When we are selecting the, first we will see the candidate. So which is directly attaching, that we have to cross check, right? In this case, obviously C double bond O same, O Cl, so Cl is get the more priority. 1, 2, Z. Right, one more question. C double bond C, OH, H2OH, hydrogen deuterium. C double bond C, for example, CH, Cl, CH, 2 I. This is first, this is second, right? Oxygen, carbon, we need to cross check. First case, oxygen and carbon. Oxygen will get the more priority than the carbon. Okay. Height 1. So, what is this? Here, first, second, same. Chlorine is coming first. Right? Chlorine is first, OH second. Right? E. Both are EE. This is a way which we have to do the geometrical isomers. I'll give you some more examples, okay, later. So next, put the heading counting of geometrical isomers. Counting of geometrical isomers. Counting of geometrical isomers. How many cis, how many trans, like that. Imagine, for example, CH3, CH double bond CH. First one double bond is there, cis and trans. Two are possible, right? Hello. First only one is there. Huh? For example, only one means what? Cis and trans are possible. Hydrogen, hydrogen. For example, Cl, Cl. Same possible. Cis and trans are possible. This is easy, right? Cis, one is there means cis and trans are possible. Now, somewhat 2 or 3 or 4 are there. That case is how we need to calculate. So that is somewhat important. So here, first we'll go with the unsymmetrical round. Unsymmetrical. Unsymmetrical means both sides. And unsymmetrical means what? For example, CH3, CH, double bond, CH, CH, double bond, CH, for example, Cl. Okay? If you cut equally, for example, here, these two equal parts are same or symmetrical or unsymmetrical? Unsymmetrical. Symmetrical means here is CH3, here is also CH3. That is symmetrical. CH3, CH, double bond, CH, CH double bond CH here. So means how many isomers are possible? How many geometrical isomers are possible? Unsymmetrical case. What are 4? So we can put for first row, we can put this is cis. This is also cis. Number 1. How can we write the cis and cis structures? If you want, I'll write here. CH3, CH, double bond C, H, C double bond C. Hello. Right. This is cis. This is also cis. Got it. Second one, what we can write? Hello. What we can write the second one? This is cis. This is trans. You can write opposite. Third case, this is trans. This is cis. Fourth one is possible what? Trans, trans. The 4 structures are possible. You can write the 4 structures. Okay, counting the geometrical isomers. Otherwise, so instead of, for example, 3 or 4 is coming, It's very difficult. Instead of that, we are using one formula. What is that formula? 2 power n. N means number of double bonds, which are showing the number of double bonds which are showing geometrical isomerism. Because all double bonds won't show the geometrical isomerism, right? The terminal ones, I'll let you know. So how many double bonds here? 2 power 2, nothing but 4. This trans, right? Write it down. Now let me know how many geometrical isomers are possible. Come on. So question number 2. All are unsymmetrical, of course. Tell me 3 bound geometrical isomers. So there are this CH2, the terminal one, nothing but CH2, right? CH2 double bond, nothing but what? C double bond HH, right? HH means what? It won't show the geometrical isomerism. Terminal ones, it won't show the geometrical isomers. These two will show 2 power 2, 4. In this case 2 power 3, all are showing 8. But in this case this won't show, this won't show. Only 1, 2, 4, 8, 2. Symmetrical. Symmetrical. Okay, what exactly symmetrical means? Same example we'll see. For example, CH3, CH double bond CH, CH double bond CH, CH3. So if you cut in the center, right, what exactly happens? 2 equal parts. Earlier, instead of CH3, I just kept some Cl like that. Now, in this case, what exactly happens? For example, we can put this is cis, right? Trans, cis, trans, cis. But the problem is, these both seems to be same. Which one? Either cis trans or trans cis, same. So that's the reason we will cut one. So only we'll get 1, 2, 3. 1, 2, 3 only possible. The both are, third one and fourth one, both are same. Both are same. In case of symmetrical, both same side, same. So that's the reason. So to avoid the confusion, here is of course we are getting 3, but here is also we have the formula. Write the formula. 2 power for even case and odd case. And symmetrical, even number of double bonds are there. Even number of double bonds. 2 power n minus 1 plus 2 power n by 2 minus 1. N by 2 minus 1. In case of odd what exactly happens? 2 power n minus 1 plus 2 power n minus 1 by 2. So of course this is even or odd? Even or odd? 2 are there. 2 means what? Even. So what is the formula? 2 power 2 minus 1 plus 2 power 2 by 2 minus 1. So 2 over here, 2 by 2 means 1, right? 2 power 0. 2 power 0 nothing but 1. So 2 plus 1, 3. 3 are possible like this. So write it down. 2 power, for even case, even number of double bonds, we need to use formula 2 power n minus 1 plus n by 2 minus 1. In case of odd, 2 power n minus 1 plus 2 power n minus 1 by 2. Found it the symmetrical one. Come on, write this 3. First one. So here is what, symmetrical or unsymmetrical? Sorry, even or odd? Symmetrical, of course. Even. Even or odd? 1, 2, 3. Odd. Odd means what? 2 power n minus 1 plus 2 power n minus 1 by 2. Okay. So 2 power 3 minus 1 plus 2 power 3 minus 1 by 2. 2 power 2 plus, right? 2 by 2. Nothing but what, Nana? 1. Right? 4 plus 2. You get 6. In case of here, 1, 2, 3, 4. Even. Even means what? 2 power 4 minus 1 plus 2 power 4 by 2 minus 1. So 2 power 3 plus 2. 2 minus 1. 1. Nothing but 8 plus 2. 10. So now in this case important. So this one won't show. This one won't show. This one won't show. So minimum for cyclic alkenes, cycloalkenes, right? Minimum 8 carbons should be there, because how many carbons in the ring? 6. 6 means it won't show the geometrical isomerism. Write it down. For cyclic alkenes, we need to have minimum 8 carbons. Only 2 power 2 unsymmetrical, 4. If it is 8 carbons are there, 8 carbons ring like this, will shows the geometrical isomerism. 8 carbons, minimum 8 carbons.